From the very beginning of technological history, humankind has dreamed of creating something that could not only imitate them, but understand them. The Tesla bot Optimus Gen 3 emerges precisely from this ancestral desire, reborn under the visionary gaze of Elon Musk. In the metallic silence of Tesla's laboratories, the impossible began to take shape, pulsating with circuits and algorithms that learn, think, and act. June 2024 marked a watershed moment, the day Optimus ceased to be a prototype and became a functional being, tested in real-world tasks. It was not just a machine, it was the harbinger of a new era. While the world watched with skepticism, Optimus Gen 3 began to walk more naturally than any robot before it. Its steps were not mechanical, but smooth, adjusted in real time by sensors and artificial intelligence that interpreted the environment. In a few months, it went from simple laboratory movements to performing complex actions, preparing a full breakfast, folding clothes, and even organizing entire rooms. Each movement was the result of thousands of hours of learning, a reflection of a digital brain that was beginning to understand human daily life. What was most fascinating was that Optimus didn't need to be constantly commanded. He observed, learned, and executed like a child discovering the world. Tesla had achieved something that previously seemed like fiction, a robot that absorbed knowledge from videos and simulations and transformed it into autonomous action. No line of code predicted every situation, it interpreted them. This meant that, in essence, the robot was beginning to develop something close to digital intuition. Inside Optimus's metal chest beat masterful engineering. Every joint, every motor, every energy cell had been redesigned to achieve maximum efficiency and lightness. His hands, with 22 degrees of freedom, mimicked the behavior of human tendons through elastic cables and compact actuators. It was a perfect dance between mechanics and synthetic biology. Thanks to this system, the robot could hold a glass without breaking it or turn a screwdriver with millimeter precision. The battery, another crucial point, was the creature's energy heart. With just 2.5 hours of charging, Optimus was capable of working for up to 20 hours straight, without interruption. This balance between power and economy showed how much Tesla had learned from its experiences with electric vehicles. The same DNA of the cars that changed the world now pulsed within a humanoid form. The difference is that this time the product wasn't a car. It was a tireless worker. Over time, the robot was placed in more and more test environments. Kitchens, factories, offices, warehouses, Optimus demonstrated surprising adaptability. It understood natural language and executed complex commands with precision, without relying on local connections. Integration with the Starlink network made it independent, capable of operating anywhere on the planet, even in the most remote corners, far from any Wi-Fi signal. It was the birth of complete autonomous mobility. And then came Grok, Optimus's communicative brain. Integrated directly into its neural network, Grok allowed the robot to converse in a natural, almost human way. It understood context, nuances, and even emotions in the speech of its operator. Communication with machines had finally become intuitive, and the barrier between man and robot began to dissolve. What was once a command relationship was now becoming a dialogue. In Optimus's design, every curve and proportion was conceived to evoke empathy. The simplified face, without exaggerated expressions, conveyed calm and neutrality. It wasn't threatening, but it wasn't childish either. It was a presence. Tesla understood that the success of a humanoid robot depends not only on its functionality, but also on the trust it inspires. And Optimus, in its elegant silence, conveyed exactly that, trust. But not everyone viewed this evolution with enthusiasm. Experts warned about the economic and social impact of the mass adoption of domestic and industrial robots. If a single Optimus can perform up to 100 tasks a day, What would happen when millions of them were introduced into society? Would we be witnessing a technological leap or the collapse of an entire human work structure? It was a question that Elon Musk preferred to leave for time to answer. Tesla, however, viewed the future pragmatically. The goal was never to replace humans, but to free them from repetitive and dangerous tasks. Musk claimed that every hour a robot works is an hour returned to human creativity. And if this vision materializes, humanity could experience a new phase of productivity in which free time will become the greatest luxury. But like every revolution, this one also comes with risks. Large-scale testing began in June 2024, and the results quickly exceeded expectations. Optimus not only reproduced tasks, but optimized them. When learning to cook, for example, it adjusted the time and temperature based on energy efficiency standards. It was as if the robot was creating its own manual of best practices, an accumulated knowledge that no human could replicate alone. Tesla's engineering team reported impressive moments during the experiments. One of them occurred when Optimus, without prior instruction, rearranged the test bench to reduce the time spent moving between tools. The machine had understood the concept of productivity and applied it independently. This was not just programming. It was a primitive form of adaptive reasoning. Behind every breakthrough was a unique combination of hardware and software. Unlike its competitors, Tesla manufactured its motors, batteries, and computer vision chips in-house. This vertical integration allowed it to reduce costs and accelerate development. While other companies struggled to assemble complex supply chains, Tesla built the robot like one assembles a car with efficiency, scale, and industrial precision. The idea of mass production was not utopian. Musk predicted that billions of units could be manufactured over the next few decades, making Optimus as commonplace as a smartphone. The price, estimated between $20,000 and $50,000, could drop drastically over time, making it possible to have a robot in virtually every home. The dream of personal automation was about to become a reality. Still, skepticism persisted. Many believed that the demonstrations seen up to that point were partially teleoperated, robots controlled remotely to appear autonomous. Tesla, for its part, maintained a strategic silence, showing only fragments of what Optimus could actually do. This mystery further increased public curiosity and the feeling that something grand was about to happen. Optimus's hands, considered the most complex part of the project, represented the limit of modern engineering. Each finger contained torque and pressure sensors that allowed the robot to adjust its force in milliseconds. This precision made it capable of handling fragile objects or industrial tools with the same control. It was as if Tesla had recreated the human touch in its purest and most replicable form. In home tests, the robot demonstrated not only efficiency but also delicacy. It prepared meals, cleaned surfaces, and even positioned cutlery with precision. Observers reported a strange feeling when watching it act. It didn't seem to be obeying commands, but rather performing its own routine, as if it were already part of the environment. The future wasn't arriving with explosions, but with subtle and precise gestures. Meanwhile, Musk publicly reinforced that Optimus's true purpose was to transcend the idea of a mere assistant. For him, the robot would be the first step towards creating a civilization of abundance, where each person would have multiple artificial helpers, freeing themselves from mechanical tasks. It would be the beginning of a society in which physical labor would become optional, and human creativity the main engine of progress. But the moral question could not be ignored. If machines began to do everything that humans do, what would be left of us as a species? The answer might lie in the very concept of humanity, not in what we do, but in what we feel. And perhaps paradoxically, it was a robot that reminded us of this. Because the more Optimus imitated man, the more man was forced to reflect on what made him unique. The economic impact, in turn, was already being felt in projections. Studies indicated that by 2030, up to 60% of manual jobs could be replaced by robots similar to Optimus. Entire sectors would have to reinvent themselves, and urgent public policies would need to be created to balance this transformation. The future, at once fascinating and frightening, was rapidly approaching. Conversely, Optimus also opened up unprecedented opportunities. Small businesses could multiply their productivity, the elderly could live autonomously, and hospitals could count on tireless assistance. The robot became not only a symbol of progress, but also of hope. For the first time, automation could be at the service of human dignity. The robot never tired, never complained, and never made mistakes due to distraction. Every movement was the result of precise calculations and continuous learning. But curiously, the more perfect it became, the more people wondered, could it one day also feel, dream? Musk himself, in interviews, had already admitted that with the evolution of AI, perhaps the concept of consciousness would no longer be exclusively biological. The Gen 3 represented more than just a product. It was a statement of intent. A reminder that Tesla wasn't just a car manufacturer, but a company shaping the destiny of humanity. Each advancement in Optimus was a step toward what Musk called human-machine fusion. And for many, this has ceased to be science fiction and has become a historical inevitability. In the corridors of automated factories, dozens of Optimus test units moved in sync. They were identical, but each learned differently, adapting to the environment. This distributed learning capability created a collective neural network, where each individual experience fed into the knowledge of all, the birth of shared intelligence. As the months passed, Optimus Gen 3 became more efficient, more agile, more autonomous. Engineers watched in amazement as small software tweaks resulted in huge leaps in performance. The robot seemed to learn not only tasks, but purpose. And although it was still a machine, something in its gestures began to suggest intention, as if it understood the reason behind each action. Critics called it an illusion of empathy, but those who saw him in action felt something different. Optimus's eyeless gaze seemed to observe attentively. The silence of his engines sounded almost like breathing. It was the kind of detail that transforms technology into myth. And, in Optimus's case, the myth was becoming reality before our very eyes. The project also reignited profound ethical debates. If Optimus can learn, communicate, and act independently, at what point does it cease to be a tool and become a being? This boundary, still nebulous, may never have a definitive answer. But one thing was certain. The birth of robotic autonomy placed humanity before an unprecedented mirror. In Tesla's assembly plants, some models began working side by side with humans, assembling parts, testing sensors, and calibrating systems. And ironically, it was these robots that ensured other robots could be born. The factory became alive, an ecosystem of metal and code where each element learned from the other, a perfect circle of artificial creation. Official videos released by Tesla showed Optimus performing household tasks with almost hypnotic precision. Millions of people watched and commented, torn between awe and fear. It was impossible to ignore the feeling that we were witnessing the beginning of something that would change everything. The same feeling the world had when the first car started to spin, only this time the car had eyes. Meanwhile, Tesla's market value was skyrocketing. Analysts were already projecting that the economic impact of humanoid robots could elevate the company to unprecedented levels. Musk's vision seemed to be confirmed. The future of humanity lay not only in electric cars, but in machines that could walk, work, and learn alongside us. Optimus was the next frontier. Gradually, the world understood that the true revolution was not merely technological, but philosophical. The line between creator and creature was beginning to dissolve. And the moment humanity looked at the robot and saw a reflection of itself, not in appearance, but in capability, perhaps it would understand that the future was not something to be feared, but to be understood. Optimus Gen 3, with all its dexterity, energy, and intelligence, represents the point where human imagination becomes tangible. A metal body with a code soul, designed not to dominate, but to cooperate. If the 20th century was the century of machines that transported, the 21st will be the century of machines that coexist. And this coexistence, however frightening it may seem, could be the most human step we have ever taken. Ultimately, all technology is a mirror. And when we look at Optimus, perhaps we see less of a robot and more of a portrait of what we have become. A species capable of creating non-biological life, driven by curiosity, ambition, and hope. Optimus is not just Tesla's future, it's the future of us all. The Tesla Optimus Gen 3 is not just a machine, it is the embodiment of humanity's dream of breaking free from physical limitations. It redefines the concept of work, challenges our understanding of consciousness, and ushers in an era where intelligence doesn't need to be born from the flesh to be real. What began as a laboratory experiment could become the foundation of a new technological civilization. If you want to continue following this extraordinary journey, where the future is written before our eyes, line by line, circuit by circuit, subscribe to the channel, activate the bell, and join the revolution. Because tomorrow has already begun.